Hello, my dear students. Welcome back into the other video where we are going to learn a new topic and I'll introduce it. This is about algebraic fractions, right? Algebraic fractions, right? We'll discuss here on how we can do some operations in algebraic fractions. Operations like multiplication, division, addition, and subtraction as such. Right, so the motive of which is that just a matter of knowing how we can simplify the fractions which are defined as algebraic fractions. Right, so here we'll have us get to know about the objectives, specific objectives as such of this lesson in algebraic expression. Right, in the discussion that we will have from now forth, we will be there introduced to expressions where we're going to express fractions to their lowest terms, meaning to say that we'll be having some kind of fractions which are defined as expressions, so we need to at least to express them in the simplest form. Like say for example, if maybe you have got a fraction, call it a vulgar fraction like 18 over 24, that is a fraction, right? Now you may be able to think of or consider simplifying this type of fraction into the simplest form. That is what it means there by reducing to the simplest form. So it means you just be there considering of dividing the talk of the numerator and the denominator by a common factor. So it means 18 over 24 is as good as having common factor for this is 6, common factor for this one is just a 4. So if 6 gets here how many times? 3 times. 6 gets how many times? 4 times. So you have got 3 over 4. So if I write 18 over 24, this is as good as writing 3 over what? 3 over 4. Right. So the way we do with the fractions which have got numbers such as 18 and 24, we're going to do the same in the algebraic expressions that we're going to discuss them here. So that's what it means by expressing fractions to their lowest term. We'll just simplify them into the lowest term as we have done here with this word fraction. Now, after we have known how to express the fractions to their lowest term, we'll discuss something about operations. How can we operate these fractions? As you remember in the primary school, you were doing some kind of operation related to like 3 over 5. They will ask you to add with another fraction like 2 over 7. Similarly here, we are going to do the addition of what? Fractions, which are defined as the algebraic fractions. The same, if you may also have some kind of situations in primary school where you were asked what? Subtract. The same here, we're also going to do what? Practice on how best we can subtract the fractions which are defined as the algebraic fractions. And the other objectives, go there. If you know how to multiply the fractions, the same here we'll discuss on how we can multiply fractions which are defined as the algebraic fractions. Then also go and learn something about the division. How do we divide the fractions? And the very last, we're just going to discuss something about equations, meaning to say we'll have some kind of word equations, word problems, which they'll need you to interpret into equations and then solve for them. Right, so simply here, we'll be discussing on how best we can solve equations that involve algebraic fractions. Right. Now, without wasting much of our time, let us begin with the first objective here, where we need to reduce the fractions or expressing them to their lowest term. Right. Maybe before I go to the first objective, let us first of all understand the issue about the algebraic fractions. Right. Word algebra comes in most of the times when in the expression there is a variable. Right, like say for example, I may have a fraction here, 3 over 4. This one is defined as the vulgar type of a fraction, where we all have we just have what? That's the numbers, like say 3 and 4, these are integers. And this is defined as numerator, and this one defined as denominator. But now the moment I'm going to include the variables within these numbers here, like say talk of 3x, and here I have got maybe 4x like that, or whatever variable may be y like that. So this one turns up to be what? Algebraic fraction. And the rated fractions, other examples, we may have 3x plus 4. That one can be regarded as a numerator, and somewhere we have got the denominator, like maybe talk over 4x minus 23. Just an example. Right. So this one, it finds the numerator, this one as a denominator. It's a fraction. Now, the existence of variable x in the fraction, we define this one as what? Algebraic fractions. So our interest will be about this type of fractions which have got variables within it. Right. Now, let's get advanced in this case by first looking at the way how we can express fractions to their lowest terms. Like I mentioned earlier, we were talking of like say 18 over 24. You may be comfortable to write this fraction in this manner, but we want to consider writing the simplest form by identifying the common factor that can get into 18 and 24. So like here, the common factor into 18 and 24 is a 6. So you let the 6 get into 18 3 times, and the same 6 getting 24 gets there how many times? 4 times. So when one writes 18 over 24 is as good as writing 3 over 4 in the reduced fraction. Right, now here we have now the fractions which are defined as algebraic. Right, by the way, let's also mention something before we start working on this. I need at least to explain clearly to you what we mean by algebraic fractions. Right, fractions are algebraic if within them there's terms which have got what? Variables such like x or y, whatever you can have. So for example, if I can have 3 over 10, this is defined as a vulgar type of a fraction. A fraction which just contains what? Numbers, which just integers as numerator and denominators. But now the moment I'm going to introduce x to have something like 3x plus maybe something x like 1. And down here I've got maybe talk of 10x minus 2. What we have here is still a fraction. But the way you can look at it, we'll be able to see that the top part is an expression 3x plus 1, and down part is also 10x minus 2. But still more, we also consider this one as a numerator, this one as what? Denominator. So if you compare the two fractions, this one here, and maybe 18 over 24, you find that they differ in one way or another. That this fraction contains variable x, but this one does not contain variable x. So this is the kind of fractions we would like to deal up with, known as algebraic fractions. Right. So these fractions are the ones that we need to know how we can add, we can subtract, we can multiply, and also we can divide. Right. So by the objectives which I listed earlier in this video, we discussed that first we need to know how we can simplify this talk of the fractions to the simplest form. So here I've got 3 examples, but we'll just solve the 2. The last one will be your exercise. You just try to work out on it based on what we're going to discuss here. Right, so the first fraction goes like this: x squared plus cx plus bx plus cb. That's what we have there. And this one is divided by 3x plus 3c as such. Right, so earlier, as I introduced the vulgar fraction, where we would have a common factor dividing numerator and denominator, the same here, you should also apply the same mechanism there. That you need to identify factors that can get in the numerator and denominator. But here it's not all that easy. Though some of us will always go for shortcuts, you find that some just cancelling x and x and then c and c. We don't do that. We don't have that type of what? Mathematics. Right, so the best way how you can do it is this. Consider every time you'd like to do some operations involving the algebraic fractions, the first and foremost thing that can help you to do the process better is the issue about factorization. Consider factorizing the numerator and denominator of the fractions that you are given. So like here, for I to identify the common factor that can get here and there, I first of all need to consider factorizing this one and the other one down here. So by the types of factorization which you have learned, you'll be able to decide which factor, which method will be able to suit this expression and that expression down there. Right, so right here, if I'm to factorize the top expression here, you may be able to realize that the terms in the top expression are always already in what? In 4 terms. As such, you can be able to group into 2 groups. So the method we used up there is that one we did in Form 2 about the grouping method. So here what we do, we are going to pair this and this as one group, and then bx and cb as another group. So once you have paired those terms, what do you do next? Identify a common factor that can get into them. So like the first group here, x squared plus cx, a common factor that gets here and there is x. So how do you write it? Here you write it x like that, then you open the bracket and let x get into x squared. So x into x squared is how many times? X. And x into cx, how many times? You talk of what? That is what? A c. You close like that. Then what you have done here, do the same for the next group. Here you also have to identify a common factor that gets here, and the results should be the same as we have in the first group. So here, if you see, the factor that can get into bx and cb is a b. So I'll write a common factor as positive b, and b gets there, I get x, b gets there, I get what? A c. You see here we have got x plus c, here again we have got x plus c. Fine. Then before we continue, let us also do something down here. So here what we have is just like, I would like to factorize this one out. This one cannot be done by grouping, but rather you just have to identify a common factor that gets here and there straight away. So if you look at 3x and positive 3c, I'll find that the common factor that can divide into the 2 terms is 3. So here I'll write my 3 like this, and then guide the 3 divided into 3x, I get x. 3 into positive 3c, I get what? A c, like that. Right, then I go further, like this. This part has to be completed. By what we discussed, it means we are going again to divide this top expression by a common factor. So if you look at this expression here, this one is added with this one here. So if you look at this term here and this term, there's a common factor, which is x plus c. There's x plus c here, there's x plus c here. So it's a common factor. So you write open bracket. X plus c into x, x plus c. The answer is x. And x plus c getting into b, x plus c. The answer is positive b, like that. So it means down here we still have 3 open brackets, x plus what? C, like that. So now when you have a situation like that, is when now we are going now to do sensible mathematics in dividing, not just there x, another x, c, and c. We don't have such type of mathematics. So we now are going to find the common factor, like 6 was getting into 18 and in 24. Here, what you see here, you find that down you have got x plus c, here again we have got x plus c. So it means that the whole of x plus c will cancel with x plus c. As such, we remain with x plus b on top, and down here we have got the 3. So it means our answer is this one here. So which means x plus b over 3 is a reduced form of x squared plus cx plus bx plus cb over 3x plus what? 3c. Right. Let us quickly again go to example b in the similar way. Right. So you look at this one, you can let's pay attention and be able to follow the procedures as such, which should always be utilized in all circumstances. Right. Now for example b, remember the last example, you are going to write it as an exercise wherever you are, or else you can discuss if you are watching this video with your friend. Right, so here we go to example b, where we need to simplify 6m squared v squared minus 4m v that what? Squared over, right, what we have there is over, talk over 3, that's a 9, m to the power 3, then talk over u, that is the minus c, you talk over, that is 4 m u to the power 3 as such. Right, so here we have got that one and this one here, that's what we would like to wake up on. Right, so now what are we going to do in this case? 6m squared u squared minus 4m u talk of what? That's a u squared again. Right. So from what I explained earlier, you'll be able to see what I said and must be true in this case. First, consider factorization. You factorize the top expression, you factorize the bottom expression, and see if you have got a common factor. But if a common factor is not there, leave it as it is. Right. So if this is the situation we have at hand, let us see quickly and see if we can have the common factor that can get here and here. Think like that. Now, if I can look closely at 6m squared u squared minus 4m u talk of what squared, I'll be able to see that here there's u squared, here there's also u squared, and here there's what? There's m. There's m here squared, there's an element of m, here there's also an element of m. So here there's a 4, 6, there there's a 4. So if you can be able to identify the common factor that can get here and there, you'll be able to see that we have got a factor which is just like a 2, and then you have got 2m, right? It means the 2 will get into 6 and we also get into a 4. It's a common factor. And the m will get into m squared and also get into the m. Right, so what do you have then? We'll also have the u squared here, which will be like m into this one. We have got what? 2m in this case. We are going even to have a u here, talk over squared, right? Then you open the bracket like this. 2 gets into 6. How many times? 3 times. And also talk of m getting into m squared. You have got m. And here you talk of the u squared getting into u squared. It's just like 1. So this one and this one they cancel. And then talk of the 2 getting into negative 4. You have got a 2 like that. And you talk of the m getting into m. You talk of that one, that m and m that they're going to cancel. Just like m getting into m once. And then u squared getting into another u squared. The answer is 1. So on top there, what we have is just like we have got we have 2m u squared open brackets 3m minus 2 as such. I repeat, a common factor for this one and that one is the 2 for the 2 numbers, and also m, the common factor is m that can get into m squared and another m. And also here you talk of what? You talk of factor u squared which can get into u squared and also what? U squared. So that's what you have up there. Down here, you'll be able to realize that, say, the common factor that can get here and there, you'll be able to see that it is talk of what? M, and then what? U. That's the common factor that can divide here and there. So let's try to divide and get that. So what we're doing here in dividing, that is the easiest way of doing the factorization. It's the factorization by dividing by common factor. So we're doing here the same as we did up there on the numerator, when we were dividing up by the what? A common factor, which is mu. So we open bracket here, mu into 9m to the power 3, then u, that m gets 9, then what? M squared. Right. Then now mu has to get into this expression again, which is negative 4mu to the power 3. So this one is just like m cancel of m, and you get into u to the power 3, which gives you u to u what? U squared. So here it be like we have m cancel of that. It means we are remaining with negative 4, and u to u getting into u to the power 3. That one gives us u what? U squared as such. Right. So now if I look at this kind of expression, I'll be able to see that there's something else that I can do to this bracketed expression here. Yes, I've divided by common factor to have 9m squared minus 4u squared. Right. So this expression is incomplete. We can factorize it further. If you look at 9m squared and the negative 4u squared, these two terms are a difference of 2 squares. Right, so the method of difference of two squares, if we were to factorize this one out, it's more like just you need just get the conjugate of each other. Need to find the conjugate of each other, which you can multiply, has to give you this expression here. Right, so how do we write? We are still going to write it like this. The top expression comes in as 2mu squared, open bracket 3m minus 2 over what? Mu. If we factorize this one by the knowledge of difference of two squares, we'll have the first bracket having 3, that is m, minus 2u. And the other bracket will have got 3m, then what? Plus, talk of what? U. That's what we get there. Right, so look at what we have done here. We are there incorporating the process of factorization. We have factorized the top expression, which is the numerator, and the bottom one, which is the denominator. So what we get from the numerator, this is what we have. And what we have on the denominator, this is what we have. But the denominator can be simplified even further, because the result of the first process of factorization gives us a difference of two squares. So as a student, you are supposed at least to complete that, because in other questions they'll ask maybe factorize completely, like, but here we are not interested with the process as it is, but here we are interested in one, working out issues about the fractions. Right, so now if we can now try to assess the result of factorization to check if we have got common factor, we'll be able to observe this. That here we have got m, which can cancel with m, because this one is multiplying by this bracket here. So here is true that m can cancel with another m like this. And this u can cancel with this u squared here to have got u. But now, if we check this bracket here, 3m minus 2m minus 2, there's no expression down here which is defined exactly as we have got up here, 3m minus 2. Here we have got 3m minus 2u. So this cannot be cancelled with this one. And don't go for shortcuts to say 2 cancelling with a 2. We don't have that. Entire expression should be exactly the other expression. Those are the only expressions which can cancel each other. Like here we've got 3m minus 2. Down here should have exactly 3m minus 2. So this and this are not common, are not alike, and this one and that one are not alike. So then what do? We read the solution as it is. So the result after dividing mu into mu squared, we have got 2 here remaining, which should multiply by this one. We have a 2, 3m minus 2. Then down here, what are we going to have? We have got these two brackets here, the binomials, which are 3m minus 2u. Then bracket, we have what? That is 3m plus u. Right, so this one is our answer. So if you look at this result, this is a simplified form of this expression here. Right. So that's the way we do. So the most important skill that we need to take each time we would like to reduce the fraction to the simplest form is the issue about factorization. So if we're good at factorizing, then everything will go better. Factorize the numerator, factorize the denominator, factorize the numerator, factorize the denominator. Then check if I've got the expressions which are alike. They should cancel each other. It means you're there, you're dividing by common factors, and the result of which is the simplified form of a particular algebraic fraction. Right, so I'll leave you question C to you do it practically and try to check what type of fraction are you going to get when you simplify this one. So do the same, factorize the numerator, factorize the denominator, identify if you have got a common factor. If you don't have it, then leave the fraction as such. Right, so now I think we need to stop here. We have learned about how we can reduce the fraction, more especially by using the process of factorization. Right, in the next video, we are there now going to start working on the operations, addition, subtraction, multiplication, and definition, and what? Division. Right, but in the video to come, we'll be there handling issues about subtraction over algebraic fractions. How do we subtract? So please, I beg you to be with me in the next video that we be able to understand how we can simplify fractions by subtraction. Thank you very much.